Hello everyone, sorry I couldn't be there today. I'm gonna go ahead and give you this video lesson on an introduction to logarithms. It responds to what we talked about last week, where we're going to be able to use some of this information to be able to solve exponential equations by working backwards. But in the process of doing that, we're also going to spend quite a bit of time with logarithms and their properties. So you're going to have two videos today. This first one is just an introduction to logarithms. The homework on this section is going to be very easy. It's just a quick introduction to the basic concept of what logarithms are. So let's go ahead and get at it. The definition, as you see here, comes from dictionary.com. The definition of a logarithm is the exponent of the power to which a base number must be raised to equal a given number. Not the most clear definition as usual, so let's look into a simpler way to think about this. A log is what we call a logarithm. It is simply a question asking what power would you raise the base of the log to get the given number. In other words, it's the opposite of an exponent. It's asking you a question about an exponent. Let's look at an actual example, because as per usual, the example is going to be much easier to learn from than some definition. So you see here we have this example, and it's the log base 2 of 32. And that's how we read that. That little subscript 2 is the base of the log. So we have the logarithm with a base of 2, and it's asking you about the number 32. And so the question that's being asked here is the opposite of an exponent. In other words, what exponent would you have to put on 2 to get to 32? So we can solve this with some finger math. 2 to what power is 32? Well, 2, 4, 8, 16, 32. That was 5 2's. So therefore the log base 2 of 32 is 5. So a logarithm is this new operation. It's the inverse operation to an exponent. What power do you raise 2 to get 32? Alright, let's go ahead and move forward. Our next example here is the log base 3 of 27. So let's go ahead and do that together. See if you can come up with the solution to that question. Remember, the question is asking 3 to what power is 27? So basically we're just going to count the powers of 3 on our finger, starting with 3 being the first power, and then 9, and then 27. So that would be 3 3's to make 27. So therefore the log base 3 of 27 is 3. Alright, log base 2 of 128. Go ahead and think about that for a second. See if you can come up with that solution on your own. Again, just count on your fingers how many 2's multiplied together will get you to 28. In other words, 2 to what power is 128? The correct answer is 8. Hopefully you're able to kind of follow the explanation here. It's just a new operation, but it's something we've never done before. So as usual, anything new can be difficult. The second form, or the second issue you're going to come across on your homework, is going to be translating logs. Because as we said, log is the opposite of an exponent. That means you can rewrite a logarithm as an exponential equation because they are opposites. When you look at the equation on the left here, log base 2 of 8 is 3. And that's because 2 times 2 times 2 is 8. 3 2's makes 8. In other words, 2 to the third is 8. So this is just basically using exponents to explain what question the log is asking. And so you're going to be asked to be able to translate from log form to exponential form, and from exponential form to log form. To do that, hopefully we can do that with an understanding, and the understanding being the question is asking when it says log base 2, it says 2 to what power will give you 8? Well, if the answer is 3, the question asks 2 to what power? So that means 2 to the third power, and then the answer is 8. How you can look at that is whatever the base of the log is going to be the base of your exponent. So we have the base and the exponent. The answer to the log is going to be the power, so we get 2 to the third. And what we're taking the log of will be the answer in the exponential form. So you're going to be asked to simply translate from one to the other. Remember, the base of the log is also the base of the exponent. Alright, we have one more thing to look at on this first worksheet. On this last section, we're going to talk about the one-to-one property, and that's going to be our first introduction to solving equations with logarithms. The one-to-one property is the single simplest property I can ever give to you. It says this: if you have the log base 4, or of any base, in this example we're going to use log base 4. Log base 4 of 3x minus 9 is equal to the log base 4 of x plus 1. Remember, log is simply an operation. And so therefore, if you're doing the same operation to both sides, you must be dealing with the same value on the inside of the parentheses. Because they're both log base 4 and they're equal to one another, we can eliminate the logs from this problem. Again, it's not going to be difficult math. It's log 4 and log 4. Therefore, we can eliminate the logs and just solve the equation 3x minus 9 equals x plus 1. There are no tricks here. It is simply solving the linear equation you see in front of you, where you minus x to the other side, add the 9, and divide by 2. So this is a very brief introduction to logarithms. Hopefully you have some understanding of what they are about, and if not, we'll be able to clarify tomorrow. Alright, good luck. Go ahead and complete this worksheet, and there will be one more video to watch and one more worksheet to complete today. Alright, good luck.